later. I forgot to start recording earlier on time, so we'll probably go back and hit the key concept again. But if not, just look at the notes. All right. So, Straveler, you asked how do we do this? So this is really, I want you guys to rewrite this on your paper. 4 times z to the 5th times 9 times z to the negative 12th.
I got it now.
So if you got it now, what do you think we do first?
Okay, so what you do first is you multiply your numbers.
Yeah, you starts with a C.
Coefficients.
Coefficients. So we take the 4 and the 9, and we get 36.
And then basically, then you like I put them parentheses and then you do times. Basically, then
Which ends up being
36
z to the negative 7. And another way that we could write this, depending on if it's asking for positive or negative exponents. Hey Grant, can you either move your Powerade bottle or stand up straight? Thanks, man. If I wanted to write this using positive exponents, it'd just be 36 over z to the 7th. Because the z to the negative 7th really says, hey, take z over 1 and flip it and apply the 7th power. So it would go on the denominator if you wanted to use positive exponents. But if it does not specify, either of them works. Hey, Jacob, you can go ahead and move a desk forward, because every time I look over there, you're staring at Wyatt, which is kind of creeping me out. Well, I'm just, if you're doing it, I'm going to call you out.
Okay.
All right, try this on your own.
Me too. I got this.
Remember, if there's no coefficient, there's really a 1. So I would find the product of your coefficients first, then find the power.
I did it.
Oh, you tried to trick me. I'm not being tricked though.
Wait, no, you didn't.
It's like
I don't think I tried to trick you. If I did, I must have done a really good job. Yeah.
Okay, about Evan Bodie. So Robert and I, our group is making a process commercial and drag. So like we were using kung fu. Everybody was kung fu fighting, but the YouTube video it's misspelled the lyrics. It was like it was like ERVYEE and body. It was like
everybody was coming.
yeah, and so we were like Evan Bodie was kung fu fighting.
I got a
That's pretty
question.
good. Yeah, real quick.
So the reason I was like, oh, you tried to trick me. I did 5 plus 3. And then I was like, no. And then I'm like, oh, there's a 1 in front of the x to the 9th. You tried to trick me, and then I'm like, wait.
But the
never
1
mind,
doesn't do
that's-
anything. Yeah. Just making, because the mistake I've seen people before say is, oh, there's no coefficients, that's a 0, and we multiply with the 0, we get 0. But that's not true at all. That's really a 1.
Why would they multiply? I don't make that mistake.
Because it was math 8, and they weren't really rationally thinking. They said, if there's no number there, I multiply by 0, right? I said, no, it's actually a 1. So, Greg, you said you got this. What'd you get?
15x to the 13th power.
Nope.
No, 14.
Because the power on the x there is actually 1. So 4 plus 9 plus 1, x to the 14th.
Wait, you do it.
So here's why. Please stop talking. I'm getting really tired of talking over you. Thank you. So this is really 5x to the 4th times 1x to the 9th times 3x to the 1st. You take your 5, your 1, and your 3, and you get your 15 when you multiply those together. You take your x to the 4th, x to the 9th, and x to the 1st, combine all their powers, and you get x to the 14th.
We're going back to
Cool.
addition, boys.
Okay, you want to know something that I still don't get?
Try the next one, see how good you are.
Yo, Mr. Hudson, you should totally come watch our commercial when it's finished.
Oh, dude, I want to. I was asking 8th grade when that stuff is going to... Is it going to be during forum?
I think it's tomorrow at Foundation.
What is?
It's tomorrow and then the day after that for some.
Can you guys come remind me so I don't forget?
Hudson, it's tomorrow.
At 20 degrees Celsius, because temperature changes the volume of a water molecule. At 20 degrees Celsius, 1 cubic meter of water has a mass of 9.98 times 10 to the 5th. Each gram of water contains about 3.34 times 10 to the 22nd molecules of water. And here's the volume of a molecule. About how many molecules of water does the droplet of water shown below contain? So I guess it's the volume of a droplet. And then it's given to you 1.13 times 10 to the negative 7th right here, or you can see it down there.
Am I supposed to write it?
So, about how many molecules of water does the droplet contain? So if you want how many molecules per one droplet, we've got the volume of the droplet, right? Is it bigger, bless you, is it bigger or smaller than a molecule?
Bigger.
Bigger, right?
Well, yeah.
How do we figure this out?
I'm confused on what they're asking.
Yeah, I'm really confused.
So we've got a mass. One cubic meter mass. We don't have to worry about the 20 degrees. Kind of a distractor, but it is like it's important, but we don't need it for the problem. Each gram, so we know how many grams it is. Each gram contains a certain number of molecules. So we could figure out how many molecules are in the entire 1 cubic meter based off its mass multiplied by how many molecules are in a gram. But what it's asking is how many molecules are in the droplet. Who can figure out how to do this? Jacob?
So first you have the volume of the droplet of water, and then you divide that by the mass. I think because then you figure out how much mass it is.
This is a tough setup. So I agree. You would want the volume of the water divided by something about the droplet, but the question is, are we going to use the mass of the droplet, or are we going to take the volume? Well, so to figure out the molecules of water, we take our cubic meters, we have 1, times the grams per cubic meter, which we've been given, times the molecules in a gram. So this will cancel out the grams. This is using our stoichiometry method where we want to cancel things. These will cancel out our cubic meters, and all we'll be left with is number of molecules. So that's why we take the meters that are given to us, which is really just 1, the grams per meter to cancel out the meters, and then the molecules per gram to cancel out the grams, because we want to end up with just molecules. So there's a couple divisions that have to happen here. Leon?
I think I might have an answer.
You think you might? What'd you get?
3.8 times 10 to the 21st.
Yeah, you rounded, but you're very, very close. So they get 3.77, but so that's the process that we would take. It's the conversion of units. You're not going to have very many like difficult problems like this, but all we're doing is converting between units. But sorry, I misspoke when I said this. This cubic meters, we're not using the entire fountain. We're just using the droplet volume. So that volume would be the volume of the droplet, which is where we get the 1.13 times 10 to the negative 7th, because that's the droplet volume. We take the volume of the droplet, and we have 2 conversion factors here. We have my conversion factor to go from meters, like cubic meters, to grams, so we use that first. And we say how many grams per cubic meter? Well, it's 9.98 times 10 to the 5th grams per 1 cubic meter, so I set that up. But if we look at canceling units, this grams unit with this grams unit will cancel out. My cubic meters is really over 1 since it's just on its own, so this cubic meters and this cubic meters will cancel out, leaving only molecules once I do the math.
Oh, I get it. Okay, I was just
It's all just deciding what do I need to cancel out each of these.
So the decimal. So you can move the
But then
decimal and
where
just
do
like add a power.
Yeah, so every time we move the decimal left, it increases the power. Every time we move the decimal right, it decreases the power. Because think about what the power is telling me to do. If it's if it's scientific notation, the power is telling me to move right. So if I move it left, I'm doing the opposite of what the power tells me, so it increases its value.
Wait, but then so small.
When we move the decimal left, right down here,
No.
it takes the
not
20 and makes it a 21.
Not that. I know that.
What's your confusion? Because I'm about to move on.
Where do you get the 9.98?
This was our conversion factor given to us, grams in 1 molecule or grams in 1 cubic meter. We just use it as a conversion factor. Like 365 days in a year, it's just a conversion factor. You just think it's complicated because it's using scientific notation, which is understandable. It is. It looks very complicated.
Scientific notation's easy.
So we start
It's just like
with
5
how
zeros.
many cubic meters because we knew the volume of the droplet. So we have to start with that volume, cubic meters. I want to cancel out my cubic meters. How can I? I can turn it into grams because I have grams per cubic meter. I then want to cancel out my grams. How do I do that? I know how many molecules are in a gram. Right here, each gram. So by using those two conversion factors, I cancel all the way to having only molecules left because it wants how many molecules.
Okay. Wait, hold up. I gotta write this down.
It's up there. All right, so same basic problem. You know still what 1 cubic meter weighs. You know that each gram of water has that 3.34 times 10 to the 22nd. About how many molecules of water are there in a swimming pool holding 200 cubic meters? So to try to make this simple, we start with volume, and we want to convert all the way to molecules. Which is when you get up into high school and you start talking about moles. You talked about moles yet? Moles is like abbreviation for molecules.
You know, there was a book that talked about like what would happen if you had a mole of moles.
A what?
Like a mole as an amount of moles as like an animal.
Like molecule. Oh. So I start with 200 meters cubed, and if I was you, I would label everything in this problem so it makes sense. Right? So that would take a pencil to write things down. Have you written down anything yet, Grant?
Yes,
Yeah,
I have.
just like
I
lost.
just dropped it.
So then, I want to get rid of my meters cubed. So I know it needs to go on bottom. Well, I see that 1 cubic meter. Well, I could use 1 then. Well, what does that represent? 9.98 times 10 to the 15th, or 10 to the 5th grams. So I can just put 9.98 times 10 to the 5th over 1. And now I know my meters cubed will cancel. Bless you. Now I want to go from grams into molecules if possible.
Oh,
What?
Because I'm trying to answer how many molecules. So to answer that, I know that 1 gram, 1 gram contains 3.34 times 10 to the 22nd molecules. That's exactly what I want.
Is that MDE?
Mole. Abbreviation from molecules.
Yeah, it looks like MDE.
Yeah, it was.
I know. It was written closely, but would not make sense. So all I really have to do is do the multiplication straight through. So if we take 200 times 9.98 times 3.34,
You get 6,666.
no, that's creepy.
Yeah.
6,666.64
That's evil right there.
times 10. Now we have to figure out our 10 power. 10 to the 5th, 10 to the 22nd, 10 to the 27th. But now if I want to write this in scientific notation, I can move my decimal 3 places left, which increases that by 3. So it's really 6.6.
Times 10 to the 3.
66664.
Yeah, we can just write 6.66. Times 10 to the, yeah, you can, if you want to round, I guess it would be a 7.
I like 6.
Times 10 to the 30th.
10 times 10 to the 38.
Yeah, you got that.
Finish it out. Show the work. If you're being lazy. Hey, Grant, you can go ahead and take a seat at that front desk in that row right there. Being back there's not a benefit to you. Questions? Does it make sense a little bit more this time?
Yeah.
Writing down the labels is extremely helpful. Keep straight what you're trying to do, what you're trying to cancel, and how we do it. Now, if it has rational exponents, what is it that a rational exponent actually means? Mackenzie? So the negative exponent tells me to flip my base. But a rational exponent. See your hands I always have up. Leon, your hand was already up.
Okay.
For you.
It means like you like root it to like if you had like to 1/2 you do the square root, 1/3 cubic root.
So this really tells me this is 81 to the 4th root to the 1st power, because the numerator tells me the power, the denominator tells me the root. So if it was, let's say, like 16 to the 2/3, this would be the cube root of 16 squared.
3.
So for the question that we have right here, it's just the 4th root of 81. Because to the 1st power does nothing, so we don't really need the 1st power. It's just 4th root of 81. Which, when we evaluate, what times itself times itself times itself would equal 81? Jacob? 3.
Wait, what? I got it.
3 times 3 is 9, times 3 is 27, times 3 is 81. Try this, 16 to the 4th, or the 1/4.
Would you do the root first and then the power?
Yeah, the most of what we see here, is, at least on this homework,
I'm doing the next one. It says root first and then the power.
Hey Ben, what'd you get here? Okay, so scoot over close to the pencil sharpener because you're talking and not getting your work done.
We were discussing the problem.
Okay, so when I come back there and your guys' notes aren't completed, it doesn't make me buy what you're saying. I'll believe you guys when you have everything up to where it needs to be.
I'm on problem 4. Writing down.
Sasha? 2. Because 2 times 2 times 2 times 2 is 16.
Oh, I get it now. Two's weird.
And that should be it. I think this is an alternative.
There's
Are
5.
are there 5 parts today?
There's 6.
There's 6.
But we have 5.
So now when we have a rational exponent that has a numerator and a denominator, Jacob?
Okay, so first the 2 the 1/2 part of it means that you square root it first.
So this is really 64 to the 1/2 to the 3rd. Because these combine to make your your 3 halves. So this really turns into, Jacob,
500.
well, what's the square root of 64?
So 8 to the 3rd.
8 to the 3rd power, which becomes 512. Yeah. Because 64 to the 1/2 power is really radical 64. And when you think about the initial power being 3 halves, you can really think of it as 64 to the 1/2 times 64 to the 1/2 times 64 to the 1/2. Which is why we have 64 to the 1/2 cubed, because there's really 3 of them. The numerator just tells you how many of them you have. So that's why we take the numerator, put it outside, keep the denominator really just told me it was square root of 64. So this is really just square root of 64 cubed. Square root of 64 is 8. Cube 8, we get 512. Let's do another.
Another one.
What the heck?
What's your issue, Ben?
Nothing.
What the heck tells me that there is an issue. What is it?
There's 2.
Okay, what is it?
They're battling to be first.
What, hand up or to solve
Yeah,
it?
'cause
Well, that's okay. I'll take a battle to solve it first.
Wyatt?
Wyatt, what's your process?
Oh, well, I did 45. I can't think of the word.
Root? Square root?
Yeah, root is 5. So then you do 5 cubed, which is 1.5.
I did 5 times 3, not 5 times 3rd.
Regardless, you're trying to piss me
I was asking
I
you
knew
a
what I
question. Well, math, buddy.
off.
And now, hopefully the last one.
Wow.
So now,
No.
it's
I
all
quit.
about like terms. Jacob's going to tap dance through the floor if I don't call on him. So Jacob, what'd you have to do first?
Okay, so first you combine. Well, since it's all multiplication, you really can just remove the parentheses.
So really think about it without the parentheses because it really doesn't matter.
And then, so you can, so you put together all of the coefficients, and you get 30. And
So 2 times 3 is 6, times 1 stays 6, times 5 gives me 30.
and then you add together the exponents for a,
So we have 2/3 and 1/3.
which comes 1.
I'm going to write it as 3/3 for now,
And then you add together the exponents for b.
which gives me. So you really get 30a times b to the 3/4. Now wait, I heard somebody say distributive property, and I think somebody was thinking FOIL.
Yeah.
Why would we not care about that here? Why do we not have to distribute? Why is there nothing like that? Still just we'll bounce back to Leon.
We only use FOIL if it's like addition and subtraction with like 2 subtract. I can say it.
So if it's a
If it's addition or subtraction.
if it's a binomial, if it's an addition or a subtraction of 2 different terms. It's like a constant term and a variable.
Yeah, what is FOIL?
It's when you multiply two.
First outside, inside.
So we've done this a couple times.
It's when you multiply two.
Say we have 3 plus x times x plus 7. I'll even put them in a different order to be weird like that. From the 3, it's got to multiply by your x and your 7. From your x, it's got to multiply to your x and your 7. First, 3 times x. Outside, 3 times 7. Inside, x times x. Last, x times 7. So we get 3x plus 21. And then we get x squared plus 7x. And then we combine like terms. Simplify. That's FOIL. Try this on your own. Kale?
4C 4/5.
Yep, this one was easier than the example. 4C to the 4/5.
Yeah, we have to say to the 4/5. You can't just say 4/5.
I can definitely just say 4/5.
No, you
Because I just did, and Mr. Hudson and I was
I got you, Holmes.
No, it's like any item with like a wolf. No, like any item with like cuts. And then like you get rid of that.
why I want to work on it.
So I'm not trying to pick on you guys, but look at like what my assessment is.
Like a paper.
So there's been your notes.
And then like we'll look at it on the top.
Don't forget to write 10-1 on your
So
homework.
when we look at
Okay.
I'll go have it.
do you have any idea how to solve this problem? No. There, no way to get out
Oh, wait, never mind, that's 3 questions. I thought that was
This is
a
my
one
issue
question.
with what's happening.
I would have left
Is
you
the fact that you're not getting down what you need to
It's still
do.
bad.
So we get into that whole snarky kind of podcast.
Oh, and you do
Just no. So tomorrow, I encourage you guys to, on your own, decide to not be beside each other.
And that's like if it's all up with.
It seems you understand the logic that is life.
Write 10-1 on the top of this.
I already said that.
Write 10-1 on the top of this. And then you can go to lunch or wherever you're headed.
Wait, does that mean we should write 10 to the first power?
Sure.
Yay!
I'm so jealous because your house is
Mr. Hudson, that's how you need to be. That's
Because I read every book in my house.
Of course, half the books are good.
No, unless I have.
Oh, yeah,